Chapter 2, Activity 3 is about the periodic table. The periodic table is a chart of elements that contains information about those elements. It was developed over the last 150 years by scientists as more information about elements became known. When Dmitri Mendeleev first organized the elements in 1871, he wrote each element on a card along with its known properties. He began arranging them by their mass, lightest at the top and heavier at the bottom, and noticed that on a regular pattern, the properties of the elements would repeat. Each time he noticed a repeat in properties, he created a new column. By creating the first periodic table, Mendeleev was able to notice breaks in the pattern where there should be elements, but no elements were known. At those breaks, he predicted the existence of new elements such as gallium and germanium. Within 15 years, all 4 elements that Mendeleev predicted were discovered, and they were found to have the properties that he predicted based on his first periodic table. As more became known about atoms, the look and arrangement of the periodic table changed. It is now organized by atomic number, and row breaks, not columns, occur when properties change. We have 18 groups and 7 periods of elements, each with their own box of information. The starred elements below the table slide up into the space where the stars are on the periodic table. There are many ways to represent those groupings of elements. The only reason that they aren't up on the table with the others is that it is a convenient way to show all of the elements on the same piece of paper. The numbers shown are atomic numbers. Starting in the upper left, they increase 1 by 1 as we move to the right. A new period, the name for a row on the periodic table, starts when the element has properties that match those of the element above it. For instance, element 1, hydrogen, is above element 3, lithium, and they have similar properties. Hydrogen also has some similarities to element 9, fluorine, and can just as easily be placed above fluorine, right next to element 2, helium. But typically, it is put above lithium. Group refers to the numbered columns, of which there are 18. Elements in a group have similar properties, which is why they are sometimes called families. Think of the people in your own family. Do you have similar features to them? Maybe the same color of hair, or a smile, or mannerisms? Those features are properties of your family, and the analogy carries over to the elements. In addition to similar physical and chemical properties, later we'll learn how the electrons are arranged around the nucleus, and elements of a group have similarities in this arrangement as well. There are several ways to break the elements into categories. One is to use the main group and transition metals. Groups 1, 2, and 13 to 18 are considered the main group elements. Groups 3 to 12 are known as the transition metals. The 2 rows marked in pink are part of periods 6 and 7, but are known as rare earth metals. These 2 portions of periods 6 and 7 are also called by the first element of the grouping, the lanthanides and actinides. Many of the other groups have names as well. Alkali metals, alkaline earth metals, halogens, and noble gases are the ones we'll use in our class. The periodic table also shows the classification of elements as metals, nonmetals, or metalloids. The workbook calls metalloids semimetals. Metals make up the majority of the elements. They are the entire left side of the periodic table and all of the bottom. They are shown in pink on this page. They have similar properties which you may already be familiar with. Metals are used for many things because of their properties. They are shiny, solid, conduct heat and electricity, and they are malleable and ductile. Nonmetals are on the upper right corner and two right groups of the periodic table. They are shown here in blue. They could be solids, liquids, or gases. They do not conduct electricity, and the solids are either brittle or powders. Metalloids occupy the space and properties between the metals and nonmetals. They are solids that can be shiny but are brittle and are known as semiconductors. Their electrical conductivity is temperature dependent. This chart has At as a nonmetal, but it is typically considered a metalloid. Electronegativity is basically a measure of an element's metallic nature. It is defined as the ability of an element to attract electrons. Metals can conduct electricity because their electrons are shielded from the positive nucleus, so the electrons jump around from atom to atom. Nonmetals do not conduct electricity, and the electrons are very strongly attracted to their nucleus. Since the nonmetals are in the upper right of the periodic table, we see the tallest columns and the darkest colors here, which correspond to high electronegativity. Notice that the opposite corner of the periodic table has short columns and lighter colors. These elements are the most metallic in character and have very low electronegativities. Knowing electronegativity and how to use the periodic table to get a general idea of the electronegativity of an element will be important when we start learning about bonding.